tells you we're going to do statistics, what do you all think of? What do you
Numbers, percentages,
Numbers, percentages, what else?
Groups of data.
Groups of data, okay.
Ratios.
Ratios. How are statistics usually presented to you, like in newspapers, magazines, television?
10,000, 5,000.
And how do they usually give you all kinds of numbers? Sometimes they're percentages, but how do they visually present statistics to you?
charts,
Yeah, lots of charts and graphs. They love to do that.
Pie charts.
So many people think statistics is just crunching numbers and doing calculations. There are way more parts to statistics, so we're going to get the right definition down here.
Why do I have the principles?
By the way, I'm sure this is the first journal question. Why do you have what? Oh, you can have an uncrinkled paper if you want. Okay, it's actually considered a science. Well, it's the science of several things. In statistics, we care a whole lot about how we collect the data. How you come up with the numbers you're going to study is a big, big deal. So it's the science of collecting, analyzing. That's where we do the number crunching, is in the analyzing step. And then reporting what we get. Do we make a graph? Do we give a verbal presentation? Do we write it out? What do we do? So it's all three of those: collecting, analyzing, and reporting info about a set of data. We're going to do all three. Now, first part of this, I know you all have seen before. If I tell you I want to make a stem and leaf plot, oh, don't moan at me.
I didn't know it. I said, oh.
Okay, by the way, can you read the green on the blue?
Yeah.
So you want?
I'm kind of blind.
Do red. No. Red would
Holy wow.
Dang, it would blend in.
Is that better? Okay. Stem and leaf plots are really, really, really useful and helpful. We like stem and leaf plots.
Yay!
Okay, and I'm about to show you why, though, and I'm going to pause the recording a second to write all this data out, and then we'll move on. You see me. Okay, so you've got the heights of these mountains. I want to turn it into a stem and leaf plot. What does a stem and leaf look like?
Flowers. Kind of looks like the...
Why do they call it a stem and leaf plot? Well, you have a little stem thing that you write some numbers down the stem, and then we put the leaves out to the side. And, well, I just made that way too big here, sorry. Because we're going to do what's called a back-to-back stem and leaf. So we're going to put our stem down the middle, and we're going to put leaves on both sides of our stem. Okay, the problem is, though, how would I do a stem and leaf with numbers this big? How do I do 15,705? Because normally, you are only allowed to have one digit be the leaf. The leaf cannot be more than a single digit. So, that would mean, do I really want to put 1570 in the stem and put a 5 as a leaf?
No, the second or the...
In this case, since these numbers are large, what actually are the valuable numbers here that we care about? 15,000, whether it's a 15,000, a 16,000, an 18,000 foot mountain. So what would be logical to put in the stem and then...
15.
Yeah, wouldn't it be logical to put 15, 16, 17, 18, whatever in the stem? The stem can be any number amount. It's the leaves can only be one digit. The leaves go out here in the open. So yeah, in this case it makes more sense. And we could do this in reverse. Some people want their 20 at the top. I don't care whether you have the big numbers at the top or bottom. Okay, so then my leaves are going to be the hundreds place. I'm going to get these grouped by thousands of feet here. So the next question then becomes, when I go to this first number, 15,705, should I write a 15,7?
7 on the left, 05 on the right.
Okay, nope, you can only do one digit. So you have to drop the 05 then. So, going downward 15,320, I would write a 15,3. Now, here's the one that brings up issue. Do I write a 16,3?
Yeah.
And that's the question. You have to decide. Are you doing this by rounding?
No.
Or what's called
No.
truncating? So we're actually going to do it both ways. You're the first group I ever had who did not want to round. That's amazing. Yes. Woo! That's a good thing. But actually, I'm going to make you do it rounded first. And then we're going to come back and do it by what's called truncating it. You can learn what a truncated number is. Okay. So we are rounding on this one. So this one would be 16,4, 18, 0, 17, 4, 16 would have to round up to a 3, 23, 15, 7, 15, 0, 16, 3, and 16, 6. Okay, so what's that roughly, just looking at it right now, what's that visually tell you about how the mountains fall in the United States? 15, 16,000 is more average, and then we have a few that are considerably taller. Now, what's wrong with this stem and leaf at the moment? I need to do the other side, but yeah, you're supposed to put your leaves in order. Okay, now, this is where you all are not going to like me because it's easier for me than for you. You either have to erase or you can redraw yours, but in my case, I'm going to go, oh, these should be in order 0377, so I'm just going to erase it and make it 0377, and it's all very nice. Because you have to have them in order, and the smallest number is always closest to the stem.
Why didn't we do that before?
Well, we didn't. You want to sit there and hunt through them and figure out? Not when I give you 100 of them, you wouldn't want to do that. So then 3, 3, 4, 6 on this one. And the good news is the rest of them we don't have to change. So there's my stem and leaf. Now, what's the one other thing you're required to put with the stem and leaf that you should have had drilled into? A key. Very good. You have to write a key. You have to explain what these numbers mean. Because somebody walks through that door right now, and they always see this stem and leaf, are they going to know what 16,3 means? No. So,
judging from the numbers inside.
you can pick any number on there that you want to do as an example. I would not pick one with a 0 because this is now trickier than you're used to. So we would write as a 16,3 represents what number? Or number?
16,300.
Okay, but there wasn't a 16,300 over here on the list.
But that's what we rounded to. Oh.
It was all the numbers who round to 16,300.
16,252.
Yeah. You have to write the whole range of numbers it could represent. So how low could you go and still round up to 300?
How low could you go?
16,200.
So you can go as low as 16,250, and then how high could you go and still round down to 16,300? Yeah, 16,349. If the 4 still makes us round down.
I think it's 277 and 550.
Now what?
All the way to the floor?
I'm not sure. I'm not following.
Oh, never mind.
Some of these were some of the other numbers on it. Okay, so if you've rounded, you'll always have a range of numbers in your key. It won't be just one number. Okay, now we're going to do this truncated too. I'll tell you right now, I personally like truncated a lot. Rounding has some error in it, but a lot of people go, oh, but truncating this will make it terrible. Now, what do I mean by truncating it?
Not rounding.
I mean, don't round it. I mean, literally just read the numbers that are there and chop off the rest to ignore the other places that you don't want. So this would say truncate it to the hundreds place if you were reading this in the instructions. So truncating to the hundreds means literally just chop these numbers off. You're going to do 157, 153, 163. You're not even going to read the other digits.
That sounds a lot easier.
It is. It's way faster because you don't have to sit there and go, should this round? You can just write down what you see.
So then the middle would be 153.
And you'll see in a minute, does it really impact how the data was spread out? So we have 15.7, 15.3, 16.3, 18.0. You just have to read these. 17. I'm just reading the digit I see. Whatever I see. You don't read the other digits. So that was the next line.
17.4.
Yeah, 17. Oh, I put that in the wrong spot. Sorry. Try one more time. 17. So I think I've already got 17.4, 16.2, 23, 15.6, 15.0, 16.2, and 16.5. As far as looking at it, did it change how they were spread out much?
No, but change with the number.
Yeah, okay. So some of the digits are changed, but are they significantly different? They both have error in them. Either way, they're not the exact number. So truncating really doesn't make much difference over rounding. You get about the same result. And truncating is faster. Now, I do need to go back and put these in order. So, yeah, I get to use the magic wand and go, oh, it should be 0, 3, 6, 7. And notice, I put the small number closest to the stem. This has got to be 2, 2, 3, 5. And then I also think it's way easier to write the key for this one.
Oh, yeah.
Now, this is the funky part. Because this is on the left side of the stem and leaf, pick any one that's not a 0. So you want to do the 15.3, the 16.2. Okay, they'll write it as 3 line 15 because what you're seeing is a 3 followed by a 15. So they'll write it backwards, which is kind of funky. Okay, so what are all the numbers that chop off to be 15,003 something? 15,003 what? 300, because we were still in the hundreds. And you could go as high as 15,399 would still chop off to be 15,300.
So what would you call truncating? Like, what does it mean to do?
You cut off the other digits and ignore them. You just cut off the number at a certain point. Yeah, chop the number, the unneeded digits off. Don't round. That's the key thing. Don't round. Okay, so on the first page of your beautiful handout you got, you'll see there's 2 tables of data, one for San Francisco and one for Los Angeles. Okay, and you need to read the instructions. One of those you're going to make a rounded stem and leaf, and the other one you're going to make a truncated stem and leaf. Now, why do we like stems and leaves? Why would we do this? If I have a set of data I need in order quickly, that's a really fast way to quickly put a bunch of numbers in order. If I had just listed those numbers out and said, go put them in order, you'd have all been having to hunt through there, particularly if you had another 25 of them on here. Sitting there hunting them, trying to put them in order is difficult. Stem and leaf gets data in order very quickly. I'm going to give you a lot of data in this chapter in a stem and leaf because it's quicker and easier to present it to you as a stem and leaf. Okay, that's a stem and leaf. Woo! The other cool thing, I wish I could do this, if I took the stem and leaf and I rotated it 90 degrees, wouldn't these numbers kind of be like a bar graph?
Yeah.
I'd have, if I rotate it, I'd have a bar for 15, a bar for 16, and then a shorter bar for 17, 18, and 19. So, anybody remember what that's called when you make a graph like that? A histogram. That's a histogram. I have no idea what number 2 is. I don't remember what order I wrote it in.
Type of histogram.
Well, we're about to talk about one. So, okay, how do you spell histogram?
Shut up.
The one who's totally unaware and innocent is the guilty party. Oh, actually, I'll stop it here, yes.